Okay, hi, good evening. So, last but not least, when you already run the conformational analysis, you already run the spotting analysis. So, this is the final analysis that should be you when you have the DSSC, a device. You want to know exactly what is the efficiency your device is capable to produce. So, you can use a potential stat equipped with a light source. You can also use a solar stimulator. You can also use a machine from solar running or from what for solar or whatever. You can calculate if the machine meet the requirement, which is 100 milliwatt per centimeter square if I'm not mistaken, and 1.5 AMS. So what happened is the important parameter or result that you can obtain from the graph. If you can obtain the short circuit current density, and you can obtain open circuit voltage, and you can know the fill factor. So when you know everything, efficiency is very simple, the formula is very simple, and efficiency equal to short circuit current density time open circuit voltage time fill factor divided by power input, then you can get. So in this case, the device doesn't have a very good efficiency, but it have 1.166%. When we compare with different material, the efficiency is quite good because it improves from one material to two material to three material. So then what you can get from this graph indicates that your supporting analysis is very good. You should have what we call that a tally result. So when let's say that the material in the rate 1 for PWGOTI to have the highest efficiency, the RCT from the EIS, the charge transfer resistance, should be smaller. And from the CV, the cathodic peak current density must be higher. And the J node and J limb from the TEFL polarization should be higher. That's how we did the research. The result must be tally to have a good research. If it not tally, it's okay, but you must explain why that thing happened. So your job will be easier if the result is tally. So what happened if you didn't have a good result? First, you can redo again. You repeat the same procedure. Maybe they have some error, maybe they have some impurities. So whatever happened, because it's experiment, we can't expect everything is good, because we can't get 100% a good result, because there is no bad result. Every result is a good result. So to be fair, you must run the experiment 3 times to know whether your sample is have a good, what we call that, standard deviation, standard error. Is it less than 5%? Is it good? Is it the result is consistent? You should run experiment before you report it. So from JV graph here, you can explain like, because you support with a lot of analysis. You support with EIS, you support with TEFL, you support with CV analysis. So a lot of supporting analysis will help you when you're explaining why you get high efficiency. Why combining the material will have high efficiency. So in the end, you can also plot a table like this. A table including the JMax, the GSC, VOC, PMax, FF, and efficiency. If you watch the other video that I post, that maybe your material can't calculate the fill factor. In that case, you must calculate the PMax first and use the formula to calculate the fill factor before you can calculate the efficiency. Okay, this is the graph of power voltage. You can see the plot of power maximum photovoltage. Okay, this you must put this measurement if your device can measure the fill factor as a supporting analysis to know how you calculate the efficiency. So overall, if you're interested to do the DSSC, you should know that if you want to study about the counter electrode, so the analysis is very simple. You must have the FTIR to know the functional group. You must have the FISM to know the morphology, XRT to know the crystallite size, whether your material is crystalline or not, to know that whether the metal oxide can be detected or not, and for the supporting analysis, EIS to know the series resistance. Lower series resistance indicates high conductivity. To know the charge transfer resistance, the smaller the better. And for TEFL, to know the J naught and J lim to high, both should be high for high electrocatalytic activity and better diffusion. And for CV, ICP, cathodic peak current density, and EPP should be lower, ICP should be higher. ICP higher for the high electrocatalytic activity, EPP to avoid over potential. And when you have all of that, then you can finally plot. You can finally have a good discussion about the DSSC. You can discuss the final finding, which is the JV, because this graph cannot stand alone. It's quite difficult if you want to put just one result in your paper. It's quite difficult, yeah, because you must support your analysis at least using 3 analyses. So I think that's all. Okay, good luck for your research. Thank you very much.